Hi, Dave Green here again. Just the final little part of using the spectral geologist. A couple more tricks. We're going to have a look at how to export mineral proportions into your spreadsheet, and we're going to look how to improve the modeling for mineral mixtures when we want to work out the composition of something like garnet using the unmixing. So taking on from where we left off last time, we have this graph at the bottom here. We've calculated the composition of the garnet by using the spectral unmixing to the two garnet end members, andradite and grossular, and finding the ratio of those. This is okay if we've actually captured all the proportions of the spectra that are at garnet. And what I mean by that, I'll show you a spectrum here. So with this sample up here is modeled in CLS. Okay, here's the minerals which we're using run modeling. Andradite and grossular are in there, and the unknown in white is being modeled by the spectrum created from mixing the library spectra together in green. And it's comprised of mainly diopside and some andradite, calcite, diopside, and lesser amounts as we go off to the right here, and we get grossular down here. Now, if we unmix to only 3 minerals, we're only going to see these 3 over here. And in fact, this data set which you're looking at has only been unmixed to 3 minerals. And the reason for doing that is because it gives you a view of the data set that captures most of the information but is not confused by noise. Especially good for when you're presenting the information to geologists who don't have a big spectral background. We've got a spectral background, we want to see more. Okay, so I need to see all this information. For instance, if I saw the first 3 spectra only, if they're what's being reported, this is going to be diopside plus andradite. But you can see the garnet is 15% andradite here, and it's 16% adding these together of grossular. So if all these spectra represent one garnet, then it's 50-50 andradite grossular, not 100% andradite, which is what we'd see if we just considered the first 3. So when I unmix to give this sort of scalar here as an estimate of the composition of the garnet, I really want to look at more spectra than just the 3. So let's go and do that. Let's bump it up to something like 7. We'll go into the log screen, and here are the TIR scalars up here. If I right-click and item to plot, we can see there are only 3 that are available. Right-click and I can modify this group of scalars, the TIR scalars, and we can see that it's unmixing using the TIR library. Okay, there's not much else you can choose from there unless you have your own library. We're including backgrounds. The algorithm we're using is constrainedly squares, and this is the name of the scalar set we're creating, and it has a mix down to 3, and we're going to bump that up to 7. And it's returning the minerals and the groups, and there's no thresholds for it. So I'll finish that. And now if I right-click on here, item to plot, we've got 7 spectra or minerals that each of the samples has been unmixed to. Cancel that, go back to our scatter graph. With the recalculation, it's reverted to standard colors. So right-click and ox color scalar, mineral colors, alternate to highlight them. So this will have changed some of the results down here to take account of especially minor components that are beyond those first 3. So interestingly, I was just looking at this sample here. It's if we assume that all these samples really are one type of garnet that's being modeled by a mixture of spectra, we can see can we believe that or not. I'd like to believe that. So, but there are some where we actually see 2 groups of garnet spectra maybe in the same sample. So if we look at those, so this sample here, okay, you can see it's banded. So this particular sample may have 2 garnets in it. A grossular rich garnet, and in the browny colors, and an andradite garnet, maybe in the more greeny material. this one here might have a similar issue. And you can see this one's banded as well. So these banded ones may have two types of garnets in them, something to be aware of as we go on. Okay, I can export this scalar now, which will be an improved version of the one we created last time. File, export, downsample. I'm downsampling again by domain. I'll average it on each domain. And I only want to export scalars. The scalar I want to export is this calculated composition from the spectral unmixing weights. And I'll also export the domain again using control click to add it. And it's going to average across each domain. And I'm going to save this as a CSV file, and I'll call it garnet weight scalar. Save, finish. Okay, go and find that. Oh, there it is, garnet weight scalars. And it's popped up on my other screen, so I'll drag it across here. Oops, get rid of that. And here it is. I've got the domain and the scalars and this material. So we'll just copy these and bring it onto the spreadsheet that we've been working on. So I have off to the side and paste it in. And you can see I've already pasted it in here. So we'll just go special values. Okay. There we go. I'll get rid of this one. So now we have two estimates of the garnet composition, one from the wavelength and one from the spectral unmixing results. Okay, so I'm going to convert now the wavelength results into something that might be some sort of how far along the track from grossular to andradite we are. And I do that by comparing the wavelength with the wavelengths of the end members, grossular and andradite. So I've done that on the next spreadsheet. So here's the wavelengths of andradite and grossular, and these are our measured wavelengths. And I can do a calculation that just does a linear interpolation of where this wavelength is compared with the two end members, and that gives me a proportion of how far along the way from andradite to andradite porosity we are using this wavelength, which hopefully will be comparable to what we get when we use the unmixing method. And you can see here these numbers are comparable. Okay, so we can get some confidence in that. And as I said, the two methods have their uses in different times. Okay, so now I will bring in other material. I want to now produce an export of the mineralogy of each of the domains. Okay, so one way of doing that is in the log screen. You can look at the results and take in some sort of eyeball average and transcribe it into your own spreadsheet. Another way is just to export the results. And the way to do this is actually using this domain tool. So this is the tool where we set up the zones or the domains that are going to be unmixed independently of each other. And I can report the results of this. And the report allows me to choose which data set I want to export. So I'm going to export the best scalars we have these. I'm going to export the columns and groups, and I want the titles to go, we'll try across, I can always transpose it. And we're going to put this into, I've already made one here, so I'll call this version 2. Save, proceed. Okay, get rid of that. Come back to our scattered graph, and now I'll open this. Here's the group weights here. And this is how it looks. So for each sample or each domain, we have the group weights have come out over here, but we get red, green, blue. We get a bit of stuff automatically generated, depths from and to and so forth. And we get the weights of each of the groups averaged for each of those samples. So this sample is 20% silica or quartz, 20% garnet, 46.5% pyroxene, a little bit of chlorite, and a little bit of carbonate. Okay, so I can copy these into another spreadsheet. I've got a duplicate spreadsheet here of that, which I'll use because this is the one, if you say, what I already had cooking in the oven. So this is the same as what we just saw, but I'm going to now use this information on the second tab. I've gotten rid of those extraneous things. And firstly, I've renamed the titles here to put them in just using proper, to put them into a sort of a sentence font. These numbers are just the way where we were before. And I've got a formula here which creates a little text showing what the highest proportion mineral is and its weight. And then this one is the second highest proportion and its weight, and so on down, and it gives a blank when we have 0 over here. So the sample we had before with 47% pyroxene comes up with 47% pyroxene. Okay, and then this column over here just concatenates all of the 1 to 7 minerals in order to create a piece of text, which I can copy. Except these, because I don't want to look at results that are less than my critical 15%, because I don't trust things that are less than 15%. So when this chlorite at 2.5% and carbonate at 10%, it's not the sort of thing I can really hang my hat on. We want it to be 15%. So I've got a little, in this routine here, I've got a little part of it that says if it's less than 15%, don't include it. And that's why I've only got pyroxene, silica, and garnet, and no carbonate and chlorite in here. Okay, so it does that. But now they don't add up to 100%. See, 47% plus 20 plus 20 doesn't add up to 100. Now we could leave it like that, and just because that's kind of being honest, we don't know what the other missing bit is. But if we want to assume that the carbonate and chlorite are kind of furfies, they're not really confident about them, I want to recalculate these to 100%. So I just copied the spreadsheet over to another one and recalculate each of the proportions to make sure that only the ones that are greater than 15% will contribute. Okay, so that's this formula here. So the trick in this one is using sum if. So it's a sum if. It's only summing if they're greater than 15%. So there's a trick. So everything else is the same, and I finish up now with a mineralogy that will sum to 100%. So I can copy that mineralogy and bring it into the spreadsheet I've been accumulating here. So I could put it right here, paste special values, okay. So here's our mineralogy. Okay. The final thing we want to do is to use this mineralogy to filter samples over here that don't really have significant amounts of garnet in them. So over in the next tab, I've already done that. So this is all the same, the mineralogy is the same, and I've just got a filter on here now. If you can't find garnet in this text here, it's not going to give a result. And so we finish up with the table now. If I hide these original ones, which are unfiltered. So for each domain, that is sample, we have a list of the mineralogy and the proportions, and we have estimates of the garnet composition using the wavelength and that recast into a percentage or proportion of andradite versus andradite plus grossular, and the same thing using the mineral unmixing weights. So there's a few more tricks of using TSG and getting things out of it. There's so much to the spectral geologist to learn, and it's just kind of fun. It's so colourful, as you can see, and I guess the key to a lot of things is the right click. There are so many things in the right click. That's where you go exploring, just have a bit of fun and see what damage you can do in TSG. Okay, well, I had fun doing that. Hope you got a little bit more out of it and appreciate what TSG has to offer. Cheerio.